In this podcast, we're going to talk about Avogadro's law, which states that for a gas at constant temperature and pressure, the volume is directly proportional to the number of moles of gas. Okay, so here we see the equation. We have the volume of the first gas over the moles of the first gas is equal to the volume of the gas at a second volume is equal to the number of moles of gas at that second volume. So basically what we're talking about here is that um, the more moles you have, the more volume you should have. Okay, so they should be directly proportional to one another. Taking a look at the molecular level view, we can understand Avogadro's law much better. So here we see that we have a gas chamber that has gas particles in it. And over here, this little guy, he's in control of the volume or the size of the box. And here we have the temperature and the pressure. There are 400 of the heavy species in right now, and we're going to add some more. Okay, and I've set the program to hold the pressure constant. In Avogadro's, the temperature and the pressure should be constant, but you can only choose one parameter. And this one models Avogadro's law the best. So we're going to add some more molecules, which would be a increased number of moles. And you see that as you add molecules, the size of the box increases, okay? So the more molecules you have, the bigger the box must be to achieve the same pressure and temperature. All right, here is a example problem. All right, so the question, how many moles of helium gas occupy a 10-liter, well, that'd be volume, flask if 17.5 grams, well, we know we need moles, so this 17.5 grams is going to have to get us to moles. Okay, so this is going to be our N1. We'll come back to it in just a second. All right, occupy a volume of 32.1 liters. Okay, so this is our second volume. So it wants to know how many moles occupy 10-liter flask. So that's our N1. If this amount, so this would be our N2 once we get it to moles, occupies a volume of this. So we need to find out how many moles this is. We know we're working with helium, so this is going to be just a simple little mole conversion. Got grams. All right, and we're dealing with helium gas. So our molar mass is about 4.0. And that's equal to 1 mole. So 17.5 divided by 4 gives us 4.375 moles. Okay, so that's our N2. Okay, now we just set up our equation. Okay, so there's our equation, V1 over N1. All right. All right, now we just plug in. So we got 10 over the unknown, the N1, is equal to V2, which is 32.1, divided by N2, which is 4.375. Okay, I'm going to cross multiply these two up. So I get 43.75 is equal to 32.1 times N1. And then I'll divide both sides by 32.1. Okay, so dividing and that gives us our N1. All right, let me plug that in real quick. All right, 43.75 divided by 32.1 gives us 1.36. Okay, and we know that we need that's 1.36, and our unit was moles. Now, of course, you need to sig fig it, but hopefully by now you've got that figured out. So 10 liters leaves us with 1 sig fig, so our real answer is 1 mole sig fig. Okay, 1 mole. And that's it. That's all there is to it.